Hello, good evening everyone. Welcome you all to the live session of NPTEL course Non-Conventional Energy Resources. This is live session 7 of the course being conducted on 21st of March 2023. The course is taught by Professor Pratap Haridas. He is professor in Department of Metallurgical and Material Sciences, IIT Madras. And this live session will be conducted by me, Rohit. I am a research scholar in IIT Bombay. So this session has been planned for interaction, one-to-one interaction between the students of this course and the course TA. So I wish that if you have any questions, anything you want to ask, so don't hesitate for asking, and even you can post the messages in the chat box. I can read your chat box in between intervals, so I will answer them, okay? Or if you want to ask it personally, you can unmute your mic and ask. So it's already 7:10, past 7:10, so let's start this session because we have waited a long time for others to join. So I hope others join at time so that we can start the session on time, okay? So, how I have planned this session, the first 5 questions are from the non-graded portion of the assignments, and the last 10 questions are from the graded portion. In between, we will also discuss the concepts which are necessary to answer these questions, and if there are anything which you can't grab from the concepts, you can ask me in between, okay? So, presenting you the question one, the question, let me take the cursor. Okay, the question one basically, let me see if somebody wants to join. Okay, so I guess I'm audible to all of you. Okay, so let's start. The first question is, during photocatalysis to split water, hydrogen and oxygen form in the same chamber. Okay, so it's saying that during photocatalysis, the water is split into hydrogen and oxygen in the same chamber. So first thing is that you need to know about photocatalysis. So there is a term called photo. Photo is something which is related to light. Okay. In this case, generally for photocatalysis, it can be any source of light, but in general we use the sunlight. Okay. What are catalysts? Catalysts are those substances which actually accelerate the rate of reaction. So if you think of something like platinum, palladium, rhodium, these metals sometimes act as catalysts in the reaction, and they actually increase the rate of reaction. So there is a question here also. So if there is a rate of reaction and catalyst increases the rate of reaction, so whether the equilibrium will be shifted to backward, like equilibrium can occur at a much faster time or something. So make sure when you are talking of catalyst increases the rate of reaction, the forward reaction, and at the same rate it also increases the backward reaction rate. So when both the rates are increased at the same speed or same pace, the equilibrium which has been shifted due to forward reaction is actually gets shifted back to the backward reaction. So the position of equilibrium doesn't changes, so catalyst doesn't affect the equilibrium. Okay. Another thing is that is talking about splitting water into hydrogen oxygen. So during photocatalyst, what happens that in the same chamber, yeah, it's in the same chamber. So we will learn more about this photocatalyst thing. So, yeah, it's a true statement. Okay, let's learn about photocatalyst then. So photocatalyst is basically acceleration of a photoreaction. What is a photoreaction? So reaction with the help of light, you can say, in the presence of a photocatalyst. So there can be different photocatalysts, the excited state of which repeatedly interacts with the reaction partners, forming reaction intermediates. So yeah, whenever there is a chemical reaction doesn't happen in just A to B. So there are some intermediate states C, which A gets transformed to C, then this C reacts with A or some other C, then the final product B is formed. Okay, so that's how. Wait, somebody is okay. So these reaction rates actually part of forming intermediates and regenerate itself after each cycle of such interactions. Kishore, can you hear me? Please mute your mic. Kishore, okay. So I request everyone to mute your mic in between. So I request everyone to mute your mic in between session to avoid any disturbance. Okay. Now, actually, in many cases, the catalyst is basically solid. Okay, like some metals or something that, upon interaction with irradiation of UV or visible light, generate electron hole pairs that again reacts with other chemicals and they generate free radicals. So I will show in the next diagram how this happens. Just for the case, you can take it as it is that key this visible light actually helps in generating the electron pairs that gets interacted and generate free radicals. So the first photocatalysis, not the first, basically for generation of or electrochemical photolysis of water, the Akira Fujishima and Kenichi Honda, they actually worked in 1972 and discovered the electrochemical photolysis of water occurred, and they basically used the titanium oxide electrode. Okay, so when they irradiated with the help of ultraviolet light and connected to some platinum electrode, so this is the photoelectrode. Okay, this is the catalyst, platinum electrode, and this is photolight. Okay, so this was the first instance of hydrogen production from a clean and cost-effective source, as the majority of hydrogen production earlier were basically from steam reforming. Okay, from natural gas reforming and gasification. So you will heard about this term steam reforming. It's a very important chemical reaction for producing hydrogen. Okay, so I urge you guys to go and search for this term steam reforming. Okay. It's basically a very important chemical reaction in gasification. Next thing is that key what happens there is a valence band and conductor band as you know in everything. So what happens when this UV light strikes it, the electron hole pairs are generated. Like here, electron. Hello. Okay, so let's start again. So what happens when this light strikes it? The electron holes pairs are generated, and in here the reaction happens in which the hydrogen. This is hydrogen ion, which gets reduced to hydrogen atom here, and similarly, redox reaction happens at this place in which the water gets converted to oxygen and 4H plus ion. Okay, so that's how this whole reaction takes place in photocatalysis reaction. So basically, it's the use of light. Light can be in any form like sunlight or any other form, visible light also, ultraviolet light also, and at the same time, the reaction which takes place at these two, the generation of electron hole pairs and similar other reaction which takes place. Okay, so I hope you guys have got a good idea about photocatalysis. Okay, so moving to the question two. Let me see if somebody wants to join. If there are any queries, yeah. Okay, so now moving to the question two. Question two is basically asking about harnessing wind energy is an indirect way of harnessing solar energy. So yeah, this is a true statement. Why it's true? Let's see. So first thing is that it's talking about wind energy and solar energy. Second thing is not talking about the direct way of harnessing. It is talking about indirect way. So what can be direct way of harnessing solar energy? So there can be solar photovoltaic, converting sunlight to electricity directly, or there can be solar thermal, converting solar energy or the light directly to heat. Okay, as per our requirement. So whatever is our requirement, based on that we convert the sunlight to either electricity or heat depending on your uses. So these two are actually the direct way of harnessing solar energy. But what happens is that whenever this solar energy, whatever on the earth, is actually a manifestation of some kind of energy, and where for this energy is coming to the earth, this is actually coming from the sun itself. So that is termed as solar energy. Now let's see actually. So what can be indirect energy? So basically, when one form of energy is converted to another useful energy source, and we need more than one process for conversion, then the energy obtained is called indirect energy. So there is a one form of energy that is to be converted to some other useful form, and there can be various steps for conversion. So these steps, because there are various steps for conversion, these are basically a form of indirect energy. So likewise, when the energy is obtained indirectly from sun's energy or solar energy via other energy forms caused by sunlight, it is called indirect solar energy. Simple. So what can be some examples of these? So examples can be wind, wave, tidal, ocean thermal, hydro energy, geothermal, and biomass. How can biomass be a indirect form of solar energy? So what happens? Have you heard the term photosynthesis? How this photosynthesis actually takes place? So there is a pigment in plant called chlorophyll. That chlorophyll actually absorbs the sunlight and converts CO2 to oxygen. Apart from that, it also manufactures the starch or cellulose or anything you can say, the food of the plant. So that what's help the plant grow. So plants are actually a form of biomass. So that's how these biomass can also be termed as a form of indirect solar energy. Okay. Similarly, if we see, I have put a pic here also to make you guys more comfortable with what I am talking about, the indirect and direct form of solar energy. So direct is basically solar photovoltaic that converts directly to energy, or solar thermal that converts to heat. And that can be wind, biomass, or different other sources. I don't know what they represent, but different other sources can also be. These, I think, this represent the hydro energy, okay, and this may be geothermal, okay. So that's how this indirect form of solar energy actually obtained. Okay, so let me see if anyone else wants to join. Okay, so nobody wants to join. Okay, so what I will do, guys, you have a look at these two questions, or I think this picture. So I will give you guys some 2-3 minutes to have a look at this picture, and try to think of some concepts which you want to discuss, or something which you don't understand about this indirect or indirect form of solar energy. Okay, so I will Okay, so again, I think there's some issue with mic. Seems okay now. Okay, so let's move to third question. So third question basically talks about the horizontal axis wind turbine. So horizontal axis wind turbine capture energy throughout the process of rotation of turbine. So is it a true statement or false statement? So yeah, it's a true statement. Okay. So what happens in case of horizontal axis turbine? This is basically a horizontal axis turbine. The axis is horizontal. So we have this nacelle and this tower. Okay, and this is horizontal axis wind turbine. The vertical axis wind turbine are like this. So this is a vertical axis wind turbine. So there is a lot of difference between these two, horizontal axis wind turbine and vertical axis wind turbine. So let me see if anybody wants to join. Okay, nobody wants to join. The- Okay, so yeah, this is so we were talking about horizontal axis wind turbines. So this is basically a horizontal axis wind turbines. The axis is horizontal. In case of vertical axis wind turbine, the axis will remain vertical. So these are much silent in operation, but for bigger installation, we generally use horizontal axis wind turbine. Okay, for you guys, what I have done, I have put a diagram on this horizontal axis wind turbine with different components of the horizontal axis wind turbine. So let's first discuss what is basically a horizontal axis wind turbine. So horizontal axis wind turbine is a wind turbine in which the main rotor shaft is pointed in the direction of wind to extract power. Okay, so this is the main rotor shaft. Okay, you can see this pointed out edge. This is basically the rotor shaft. This is the rotor shaft which have gears basically which converts the rotation of the wind turbine blades to rotation of motor which generates electricity. Okay, so these are blades, this is a rotor, this is called nacelle, this is high speed shaft. It converts the low speed of rotation from rotor to high speed rotation. Okay, this is basically your drive just to move the nacelle in the direction to orient it towards the direction of wind. This is tower, this is yaw motor to rotate the nacelle. This is brake in case some high speed wind is flowing, so it can damage the structure, so there are brakes also. This is generator, this is controller, this is anemometer to sense the velocity of wind, and this is low speed shaft, this is high speed shaft. Okay, so I think most of the uh, components are much easier to understand, and you guys must have got a good idea about horizontal axis wind turbines in this picture. Okay, so horizontal axis wind turbines are generally used for high power installations like 5 megawatt, 2 megawatts, similar types. And also the horizontal axis wind turbine are much noisier in operation. So if you guys have a home anywhere near the wind farm, so you must have understand how much noise these wind turbines actually generate. They generate quite a huge amount of noise, and houses near these wind farms are not suggested. Okay, because of the noise generated by these horizontal axis wind turbine. But compared to this horizontal axis wind turbine, we have vertical axis wind turbine, which are much quieter in operation than this horizontal axis wind turbine. Okay, so yeah, there are various terms which we will discuss in upcoming lectures. Okay, so as of now, this is quite a proper introduction of a horizontal axis wind turbine. So I think if there are any queries, you guys can ask your queries in the chat box. So let me see if you guys have any queries regarding this. Okay, no queries. So what I will do, I will give you guys some. What I will do, I will give you guys some time to go through this horizontal axis wind turbine. So you can ask your queries in the chat box, and I will answer them one by one. Okay. Mm-hmm. So in case there are no questions, then we can move to next slide then. Okay, so question 4 is the band gap of a single material photocatalyst being greater than potential window corresponding to the electrolysis of water is a sufficient condition for it to be used for electrolysis of water. So talking about the band gap of a single material photocatalyst, yeah, this is a required condition, but it is not only a sufficient condition. Why? Because the energy contained in the light which is striking these and generating electron hole pairs, so that is also quite a requirement. The amount of photocatalyst, the catalysts which we are using. So yeah, different other things are also important as of now, so it cannot be called a sufficient condition, but yeah, it is a required condition. Okay, so this condition is particularly required for having to perform the photocatalysis reaction for electrolysis of water. So as of now, this is a true this is a false statement. Okay, so the correct answer is false. Okay, so last question of the non-graded part of the assignment. So let's see this last question. The photoelectrochemical reaction involves the flow of electrons in an external circuit. So yeah, basically what is a photoelectrochemical reaction? So anything which involves light and the flow of electrons in the external circuit, so that is basically a photoelectrochemical reaction. So what this question is saying, कि photoelectrochemical reaction involves the flow of electrons in an external circuit. So yeah, it's a true statement. Whenever there is a flow of electrons in the external circuit due to the different anode, cathode here. So yeah, this is termed as photoelectrochemical reaction. Okay, so that's how this reaction actually works. So it's a quite a true statement. So basically, uh, there are different reactions, photolysis reaction, photoelectrochemical reactions. So much of these reactions have different uh, uses. For something like electrolysis of water can be done through photocatalysis, and much of research is in this area is going on. So to search for a particular frequency or wavelength of light, to search for a particular photocatalyst that can actually accelerate the reaction and make these reactions possible, because earlier these reactions were not so possible, but now with the help of time and different research output, much and more of these reactions are actually possible as of now. Okay, so that's how these reactions actually work. Okay, so yeah, with this the uh, non-graded part of the assignment is complete. So if there are any questions with this non-graded part of the assignment, I will request you all guys to go through this non-graded part of the assignment, and then we will go through and ask your questions. Okay, and then we will start the graded part of the assignment. Okay, so these graded questions have been taken from previous run of the course, so don't expect that I will take question from this run, this run of this course, because the question from this run of this course has to be solved by you. If there is any issues or any problems which you want to discuss, so the live sessions are actually planned for that only. Okay, so as of now, please go through these questions which I have discussed and post your queries in the chat box so I can read your queries, and then we will have a great discussion on that. Okay. Okay, so let's start this session again. So since there are no questions from you guys, so I will move forward and take the graded part of the assignment. Okay, the question number 6, it basically says, so what way I will do, I will go slow with these questions. Okay, so if there are any doubts from your side, you guys can easily ask. Okay, so in a photoelectrochemical reaction of water in the presence of TiO2 photocatalyst, so yeah, this is the photocatalyst TiO2, titanium oxide. Dash and dash gas are generated at anode and cathode respectively. So this is basically a conceptual question which you need to remember, guys. Okay. So basically, in this case, this is not the case. CO2 is not generated in photocatalysis or photoelectrochemical reaction of water. Okay, so you can cut it out. So only option remaining is O2, H2, and H2O2. So basically, at anode, oxygen is generated. Okay, and at cathode, hydrogen is generated. So remember it. Okay, so this is O2, this is H2. Okay, so I think we have this discussed in here also. I think, yeah, this is H2, this is O2, so it's basically a cathode, this is at anode. Okay, so, so what I will do, you guys please spend some time on this question, and if there are any question, you guys can ask. Okay. this is not recorded. Okay, so let me tell you again. Okay, this is here. So I will explain this question again. So you have remembered electron hole pair. Okay, so what happens? First, the incoming photo radiation is there, step 1A. Then electron hole pair generation, these two. Then what happens after electron hole pair generation? The migration of electron towards the outer surface. Electron migrates the outer surface, hole migrates to outer surface, and then at the outer surface, the reaction actually takes place. So the D is 5. So A3, B2, C1 and D5. So the correct answer here is answer D. Okay. So please go through this question, and if you have any doubts regarding this question, you can always ask your doubts here. नहीं यार, no. Okay, so let's move. Let's see if any of you have asked any questions. Okay, fantastic. No question. Then move to the next question now. Okay, so let's move to the next question. Next question is use of co-catalyst in the process of hydrogen oxygen gas generation helps in increasing rate of electron hole recombination. No, actually co-catalyst doesn't help. What is co-catalyst? There is a catalyst, so if you add any another catalyst which is to aid the process, so that's called a co-catalyst. So use of a co-catalyst in the process hydrogen oxygen gas generation helps in increasing rate of electron hole recombination. So it's talking about recombination. Why it will recombine? So it will not recombine. It's simply use of co-catalyst. Why do we use a catalyst? So that is for generation of electron and hole. Okay, electron hole pair. So no, this is actually a false statement. Okay, so this is not the correct statement regarding the usage of co-catalyst. Okay, so please go through this question now. Okay, so let's move to the next question now. The sacrificial agent is added to increase the electron hole pair recombination reaction. So, so this is basically a false statement. The sacrificial agent is not added to increase the electron hole pair recombination reaction. Okay, so So what is these sacrificial agent? So sacrificial inorganic electron donors like sulfide S2 minus or sulfite SO3 2 minus can act as a sacrificial inorganic reagent for the photocatalytic hydrogen generation because they are very much efficient electron acceptors. Okay, so enabling the effective separation of the charge carriers. So it's not it doesn't increase the electron hole pair recombination, rather it helps in separation of these electron hole pairs. Okay, so this is basically a false statement. Please go through this question once again. So it's a very much important conceptual question that you need to understand so that you guys can uh, easily answer the questions which can be asked in the final exam. Okay, so these are simple questions. Let me see, no question here. So these are simple questions which are asked up to now. So you guys can easily go through these questions and answer your questions which are asked in the exam. Okay, let's move to the next question now. So let's talk about particle size reduction dash the chances of dash. Okay, so particle size reduction decreases the chances of encountering a defect en route the surface. Okay. So this is the correct option. So let's see the first option. Okay, the particle size reduction decreases the chances of electron hole recombination losses. No, this is not correct. So increases the hole pair recombination and loss. It cannot have a hole pair recombination. It can be electron hole pair recombination. Okay, so this is also wrong. Increases encountering a defect and root surface. No, it doesn't increases encountering a defect. It decreases actually encountering a defect and root surface. This is also wrong. So the correct answer is answer C. Okay, so please look through this question for a few minutes, and if you have any queries, please ask your queries. Okay, so let's move to the next question now. Let me see if let me see if somebody wants to join. Okay, so if there are any queries, you guys can ask it here. So yeah, okay, so let's move to the next question now. So next question is match the advantages and disadvantages of different types of windmill. So it's basically saying wind turbines. Okay, so vertical axis, horizontal axis, which I have discussed in the earlier slides also. So if we see the advantages and disadvantages, so actually the vertical axis wind turbine has a more turbulent flow of air near the ground. Yeah, because of its shape. So okay, so near the ground it has a more because the horizontal axis wind turbine are like this situated much high above the ground. So yeah, this is A3 and B is basically horizontal axis B1 is easier access to stronger winds. Yeah, because the stronger winds are generally at the top. So yeah, easier access to due to its height. Another thing is that it's A2 wind energy not captured through the rotation. Huh. Yeah, we don't have rotation here. Okay, so it not captured through the rotation. So A2 and B of the tax of turbine complexity with respect to setting up. Yeah, because we have to install the tower, we have to install the gear drives. Here, no any such requirement you just can install, but here a lot of requirements. Okay, the correct answer is A3, B1, A2, B4. Okay, so please go through this question, and in case of doubt, you can always ask. Okay. Okay, let's move to the next question now. No queries as of now. Yeah, okay, so recording is going on. Okay, so yeah, the next question is a large wind turbine of 2-3 megawatt with 35% of capacity factor installed in a region. Then the number of wind turbines required for fulfilling the energy consumption of 500 exajoules will be dash millions. Okay, so we have two answers here, 22 and 15, B and C. Why B and C? Because it's saying 2 and 3 millions both. Okay, if it's talking about 2 megawatt or only 3 megawatt, then we will have one answer depending on that. So basically it's talking about so it will be between 15 million to 22 million. So how it is calculated? So this is the basic concepts which you need to learn, because this concept will be asked in the exam. So okay, so for 2 megawatt, how many watt in 2 megawatt? So 2 into 10 power 6 into what was the capacity factor again? 35%. Okay, so I've taken 35% into 3600. What is joule per second? You remember? So you have to convert it for annual, calculate it for annually. So just take it 3600 hour, 24 hour in a day, 365 days. So annually this much energy will be produced into X, which is the number of wind turbines. Number of wind turbine which you need to know. And how much you need to produce? 500 exajoules consumption. Okay. So that is 500 into 10 to the power 18 joules. So when you calculate it, the value of X will be around 15. Similarly, for 3 megawatts, when you calculate the X, it will be around 22. So both of it is correct, 15 and 22. Okay, so I am sure that you must have got the concept here. So if there are any queries, you can ask it now. And be sure, don't get these questions wrong. These are very easy questions which you can always try, attempt and solve it. Okay. Okay, so let's move to the next question now. So, no question as of now. So let's move to the next question. So it's saying that key what will be the total approximate space requirement to install all the wind turbines calculated in question 7. So yeah, it was calculated at 22 million tons for 3 megawatt. So generally zero point 0.5 is the square kilometer that individual wind turbine takes. So for zero point 0.2 for 22 million wind turbine, you just multiply these two. Okay, so it will be around 11 million square kilometers. So the correct answer is 11 million square kilometer, answer C. Okay, so I hope you have got this question. So it's already let's move to the next question. Name the points A, B, C, D in the given diagram. So points A, B, C, D. Okay, so at point A, what will happen? Because the wind speed is quite low, so no power will be generated at this point. Okay, at this point. At point B, power is available in the windmill. Okay. At point C, the rated power is actually reached. This is the rated power. Okay, that is the rating of wind turbine or windmill. Okay, and point D is basically windmill shutdowns. So you can see no power is getting generated. So yeah, point A, B, C, D, these are 4 points that you need to look into. Okay, so basically you have to take care of wind speed to generate a power. It cannot generate power at all the wind speeds. So yeah, this is basically the curve which is very much utilized for looking into the power generation. So I will suggest you guys to please have a look at this curve. Then we will discuss the next question and then we will end this session. Okay, let's move to the next question, which is the last question of this session. So basically, it's talking about the wind energy is calculated using Bernoulli equation. So what is a Bernoulli equation? Bernoulli equation is Ke, kinetic energy, plus potential energy plus pressure. That is pressure energy equal to constant. Okay. So kinetic energy is rho v square, potential energy is rho gh, and P is pressure is constant. So the correct answer is answer D. Yes, so just remember kinetic energy plus potential plus pressure is constant. So half rho v square rho gh upon plus P equal to constant. So thank you for attending this live session. So if you have any queries, you can always write me at this email address, or you can ask your questions in the discussion forum also, so that everyone else can benefit from your question. Also, this live session is recorded, so the recording of this live session will be uploaded on the YouTube channel, and the link will be shared with you in the problem solving session of problem solving tab. So kindly visit the tab and visit the link also, so you guys can easily understand the question, or you can also post the question in the YouTube videos, or you can ask it in the discussion forum. Okay, so I hope you guys have enjoyed this session. If there are any queries, you are always feel free to ask your queries. Okay, so with this, I am ending this live session. So, okay.